I'll set this to 0 and I'll say okay.
What is it? Don't tell him.
These are the columns.
We'll pass.
I will check the stress in these columns due to this combination. So I'll go right mouse click, result settings, beams, which also the same for columns, contour, stress. What type of stress do we want?
Axial.
We want axial, and then I'll say okay. So that's axial stress in the columns. And as you can see, they are all under compression. And the high value of stress is this blue one. Where are the blue ones?
The middle two.
This one. I'll zoom this area. So these two columns, they are the ones with the high stress. What is the stress value of these columns? 1, 2, 3, 1, 2, 3. It's 12.5 megapascal. Is that okay?
Yeah.
We have complete up till 32, huh? So this is 12.5, so that's
Absolutely okay.
yeah? Now, as you move up along these columns, you will find that the stress is very low. So actually what one can do is one can reduce the size of these columns.
Yes.
Because we don't need all of this material, isn't it? Right? Okay, now we have checked these columns. There are lots of them are over designed, but none of them is unsafe. I'll go to the beams. I'll do like this. I'll put the beams back. These are the beams. Now I want to have a look at the beams. So I don't need the columns. So I want to select the columns and hide them and leave the beams only. So I'll do Control A. This will inverse the selection. So whatever was unselected will get selected, and whatever was selected will get unselected. Now when I hide, I'm hiding the columns, and I'm left with the beams. Yeah? Now what we should be looking at in the beams is what? Are we interested in axial forces? We are interested in
Bending moment.
So right mouse click, result settings. Now I'll go to diagram, bending moment, and I'll put the bending moment. Now when you see it like this, you can't see anything. Right mouse click, result setting, and I'll reduce the size of the diagram. I'll reduce it a bit more.
So good.
Yeah? So this shows you the bending moment diagram, and you will find that this bending moment is sort of like similar between the different floors. It's more or less, it will be similar. You can zoom in one floor, and you can check the values, and you will find that the values are not far from each other. For example, this one is 523, 528, and so on. So these are the bending moment diagram for these beams. Usually one would do like this. We can usually one would look at one floor only, because we don't need all of this. We just need one floor. So I will hide everything except of the beams of one floor. I'll do this using this one, select by region. And I'll select a region. I'm defining a region which will include, okay, I don't want UCS, I want Cartesian. I'll select this region. I'm just creating like an envelope which will include these beams. I'll use this one, select partially selected, so if a beam is partially within this envelope, it will get selected. And I'll say OK. Now all of these beams are selected, right? I'll do like this, Control A. By doing this, I've unselected these ones and selected everything else. What will I do now? Hide.
Hide the select.
Hide. I'll go to this one. I'll press this one. It will put back the things that were hidden, and then I'll press on it again. You see, everything now is hidden except for this one. Except for this one.
靠！你的经验太低了，比起来这毕竟8次操作了。
And this is the bending moment of these or the floors of this beam. What will happen in reality is you will take this bending moment value and you will push reinforcement to resist this bending moment. Now that's how we select or how we check the bending moment. I will look at plates. So I don't need these beams anymore. So I'll hide them. I'll put the plates. Now let's check the deflection. Where would we have the highest or the maximum deflection? Where would we have the highest deflection value?
The edge of the circle.
We will have it at the end of this cantilever. You see this one? This is 2 meters and it is not supported by anything. So most probably you will have high deflection here. How can I see this? Right mouse click. Result setting. Plate. Contour. Displacement. DZ. Say OK.
Well, every beam, every plate is different.
It's still okay, so it's really not that bad, but we can check these values from using this one. So I'll take this one, and the displacement here is 9.5 millimeters,
10 mil.
almost 1 centimeter. Yeah, which is, we'll leave it like this, so we'll accept this, and we will look at something else. We'll look at bending moment in slabs. I'll do like this. I'll set this back to 0, and I want to look at one. Okay, I'll look at all of them. Result settings, contour, moment, and we have moment in 2 directions, X and Y. So I'll look at X global. Sorry, I'll make X global. Are you following?
Yeah.
And I'll say OK. Now, it's also expected that they will all be more or less similar. So I'll just look at one of them. I just want to look at one floor. So I'll do the same thing again. Select by region. It didn't select the place because plates are not active from here, isn't it? I'll make plates active and select by region. And you can expand or contract the region from here. You see how you can expand it? So everything is included within this region now. For all of this place. So I'll say OK. Now all these places get selected. What will I do now?
Control A.
Control A. And then click here. Now we are left with this one.
Come on, shame on you. Shame 你哥是一种 shame
That's the
逢时
bending
役。
moment in x direction. And you have negative and positive bending moment. Can you see this? There is a way to see this bending moment. You can see it in a different way. I'll use this graph. I'll just draw a graph versus position. Say okay. Quantity. I'm drawing a graph with the bending moment, which is the bending moment of the plate. So I should have the plate selected. So I'll select plates from here. And I'll select moment from here, and I'll select global to be same as this one, XX. Right? And I'll say position. And I'll say from here, I'll do it from here till here. And I'll say 13 intersections points were found. I'll say okay. What is it?
Bending moment diagram.
That's the bending moment diagram of these plates. You can do like this. 3D graph. I'll put it like this. Got a phone? Can you see your bending moment on the plate?
Yes.
Yeah? And actually you can do lots of other things as well. It shows you that this red one, that's where you have positive bending moment.
Negative.
And these values would be correspond to this one. And the
Right.
one here, that's where you have the negative bending moment with these values. And actually you can put the values on the graph.
26分钟。
马上记得出来，后半部分根本记不了，脑子记。
就看着它，然后凭记忆啊。
太难了。
嗯？
太难了。
不难，我都能记得住。
看意思你记得住。
嗯。啊 ，it's a finger。
真的把奇葩类，快去。
Can you see the bending moment values?
Yes.
So, sort of like you don't have to check a color and then go and see what this color is. If by putting this graph like this, it will give you straight away bending moment. This location is this amount and so on. Okay. So now we have checked the normal forces in stress in columns, bending moment in beams, and then bending moment in slabs. I'll let you do the same thing.
Sir?
Yeah?
Sir, can you tell us where you saved that file so we can check out answers against yours? Can you said in like most of this DVD?
Or it is saved here.
Oh, okay.
I'll try to put it in Moodle and then you can get it from Moodle.
That's good.
So try to do this and I'll try to put it in Moodle and then you can get it from Moodle. Okay. Yeah?
你知道我昨天见约我吃螃蟹是吧？然后一下夸出来，然后没理他，然后就吃完螃蟹之后，我去吃奇异果，我靠！一洗的时候全部进去了。
啊，你吃的什么清蒸螃蟹啊？新鲜的活的吗？
Yeah, and then you try to pick it from Moodle.
多少钱买的？我比较感兴趣是这个，我不管你的手。
不告诉你，这个是清真的，
清真的，哎，那活的你们那卖多少钱啊？
这个很便宜，15块。
多少钱？35块钱一公斤。那死的。
没有，会飞蟹。